Good evening. Okay. So in our last class, we did. Did you write all the notes, earlier notes? Yeah, you followed in online. Did you? No. Today is the first lesson, right? It's fine. Okay. So I think you can watch the videos. Okay. Right. So let's start the lesson today. Right. So today I'm going to revise the lesson what we studied in our last class. Okay. Right. So in our last class, we studied about we start the unit oscillation and waves. In the oscillation part, we studied about the periodic motion. So the first one is periodic motion. So periodic motion is like the same motion, it is happening again and again and again with the same time period is known as periodic motion. Okay, right. Something like a circular motion or like the rotation of the earth, it is rotating within the 24 hours time period, and it's again and again and again it's happening there, right? Okay. And also motion of a simple harmonic motion, like a motion of a simple pendulum, the motion is something like this. Okay, right. So within the same time period, it's happening again and again and again like this. Okay, right. So this is like the periodic motion. The second one we studied, it's what? What is the oscillatory motion? Oscillatory motion means there is a fixed point. Okay, there is a fixed point. So the motion is happening towards this fixed point back and forth. So there is a fixed point here. The motion is happening like this. Okay, or something like this also. If this is the fixed point, when the simple pendulum is moving, it will move like this. So there is a fixed point, it's moving back and forth within the same time period is known as the oscillatory motion. So the oscillatory motion should be something like this, or something like this, or something like this. There should be a fixed point and it should move back and forth. That is the important note here. Okay, right. So this is oscillatory motion. The second one is very important. That is the one we studied in our last class. We proved the equations as well. That motion is, what is that one? Simple harmonic motion. Very good. Simple harmonic motion. Okay, right. So simple harmonic motion, if the oscillatory motions happens in a straight line, that is known as simple harmonic motion. So in a simple harmonic motion, so if this is the bob of a simple pendulum, normally when we are oscillating this simple pendulum in a big angle, within a big angle like this, so this is the very big angle. The path, it will be looks like this. This is a curved path. So if we want to make this curved path into a straight line, but we want to know what we want to do. We want to reduce the angle here. So you can watch the recording, I think, right? So in the last class, I clearly explained. So when you reduce the angle, the motion is something like this. So this is now in a straight line. So this is the fixed point. So we know that this is a simple harmonic motion. So what are the examples for the simple harmonic motion? One is simple pendulum. The second one is spring mass system. The third one is the spring mass system means there is a spring here. So we connected a mass here. So when we pull this mass and leave this, how it will be looks like? This will looks like this. The motion should be like this within the 2 point. So there's a motion something like this. So this is known as simple harmonic motion. And also we can make this spring mass system in a horizontal plane also. Okay, so like this, right? So these are examples for the simple harmonic motion. And we move to physical quantities related to simple harmonic motion. But we studied what is the first physical quantity? Displacement. So the displacement x. Okay, right. So if a particle is moving something like this, if a particle is moving in a simple harmonic motion, so this is the fixed point. So if the particle is here, we know the displacement is now measured from the fixed point. What is the displacement at the fixed point? It is 0. X is equal to 0 we studied. X is equal to 0 here. If we took this side positive, and then we know that the opposite of this direction should be negative. So these are the main thing we studied in the displacement. The second one is amplitude. What is the definition for the amplitude? The maximum displacement is known as amplitude. So where the particle can go here in this simple harmonic motion, here, this is the maximum displacement this particle can travel. So these 2 points are known as, so if this is positive amplitude, this is negative amplitude. So these 2 points are known as this amplitude, right? The third one, what we studied, the third one, periodic time or time period. So what do you mean by time period? The time period take to complete a complete oscillation is known as periodic time or time period. So we studied about this one. And the fourth one, what is the fourth one is frequency. Frequency is equal to 1 over capital T, 1 over time period. So these are the parameters, or these are the physical quantities we studied in our last class. And also, right, let's move to the simple harmonic motion equations. Simple harmonic motion equations. Can you tell me, guys, what are the equation we studied in our last class? What is the equation for the displacement? X is equal to, can you remember? Take out your note and check the equations. What are the equations? Tell me. X is equal to A sine theta. Can you remember? We proved in our last class with a circle. We proved all the equation, all three equations for the displacement, for the velocity, and the acceleration. Is that is in your notebook? Yeah. That is the equation. Those equations we studied. Can you remember? Yeah. So in the simple harmonic equation, look at this one. For the displacement is equal to A sine theta. For the theta, what can we substitute here? Omega t, isn't it? Yeah, omega t. So when we substitute omega t here, we can get the equation x is equal to A sine omega t. A sine omega t. The second equation here is, guys, for the velocity. Can you tell me what is velocity? V is equal to A omega cos theta. Very good. A omega cos theta. So it's A omega cos theta. Oh, for the theta, what can we substitute? Omega t. So here V is equal to A omega cos omega t. Cos omega t. The third one here is acceleration. Acceleration is equal to, tell me the equation, minus A omega square minus A omega square sine theta. For the theta, we can substitute here, guys. A is equal to minus A omega square sine omega t. These are the equations we studied in the last class, isn't it? Right. So these are the things we studied in our last class. Right. Look at this, guys. This is very important. Okay. From here, we are going to start the lesson from now. Okay. Right. So these are the equation for the simple harmonic motion, for the displacement, for the velocity and the acceleration. Okay, right. I'm going to write down a note here. Okay, look at this one carefully. Look at this one carefully, guys. Okay, right. I'm taking this equation, guys. A is equal to minus a omega square sine omega t equation. Sine omega t equation. Okay, right. Here, what I'm going to do here is I'm going to make a simple change in this equation. Okay, right. A is equal to, look at this one. A I'm writing like this. Omega square A sine omega t. Look at this equation. A is equal to minus omega square A sine omega t. Can you tell me what can we substitute for this A sine omega t here? Look at the board. So what can we substitute for the A sine omega t here? X. Yeah, X is equal to A sine omega t, So we can substitute the X for this one. So look at this equation. A is equal to minus omega square X. So this is the equation for the simple harmonic motion, guys. So this is the important equation. Okay, this is the equation for the simple harmonic motion. If a motion happens in this format, that means if a motion satisfy this equation, A is equal to minus omega square X equation, that means that motion is under simple harmonic motion. So somehow like they are giving some examples like let's say something like this. Okay, right. So there is a water surface and a cylinder is oscillating up and down. This is a water surface. A cylinder is oscillating up and down like this. Okay, it is oscillating up and down, something like this. So this is a simple harmonic motion, no? Right. So they are asking, prove that this motion is a simple harmonic motion. Okay, they are asking to prove that. So if we want to prove that, what we want to do here is we want to get an equation for the acceleration of this motion, right? We want to get an equation for the acceleration. Okay, right. If the acceleration equation is looks like this in this format, A is equal to minus omega square X, that motion is known as simple harmonic motion. Okay, so we want to prove that the equation is something like this. Okay, right. We will do questions on this one, so no worries. Okay, right. So so this is the note here. This is a very important thing. So now tell me, guys, this A is equal to, this acceleration is equal to minus omega square X. For a certain simple harmonic motion, omega is a constant. You got it? For a certain simple harmonic motion, omega means what? Angular velocity. So the angular velocity is constant. Okay, right. If the omega is constant, can you tell me A is what? A is proportional to X. Yes, A is proportional to X, guys. And also, in this simple harmonic motion, the beauty of this simple harmonic motion here is, students, acceleration is always towards the center. Acceleration is always towards the center. That's why we are putting this minus here. In the last class, I explained you this point. Can you remember? In the last class, I remember that velocity and the displacement is in the direction of the displacement, but the acceleration is only towards the center. So that's why I put the minus here. You got it? Right. So A proportional to X. So in the first class, I told you that I gave you the definition, another definition for the simple harmonic motion. So now what we are going to do is we are going to read the definition what they given. Okay, right. Take out the definition under the simple harmonic motion. Okay, right. Look at that. Look at the definition. Okay, simple harmonic motion. If the acceleration of a moving body is always directed toward an equilibrium point. This is very important point, guys. Okay, right. In simple harmonic motion, acceleration always towards the center or always towards the fixed point. Please highlight the point. Acceleration of a moving body is always directed toward an equilibrium point. Okay, right. Its magnitude being directly proportional to the distance from the same point. Okay, right. Look at this one. Look at this one. So the magnitude of the if the omega square is constant, the magnitude of the acceleration is proportional to x. That means the acceleration is proportional to the displacement. If the displacement is high, the acceleration is high. If the displacement is zero, tell me, substitute the zero for the x. What's the value for the acceleration? Zero. If the x is zero, the acceleration is zero. So if the x increases, the displacement increases, the acceleration increases. The x decreases, the acceleration decreases. And also this acceleration is always towards the center. Okay, right. Its magnitude being directly proportional to the distance from the same point, then the motion of the body is called simple harmonic motion. Okay, please highlight the point. Magnitude being directly proportional to the distance from the same point. Okay, these are the two main points. If one motion is a simple harmonic motion, magnitude of the acceleration is directly proportional to the displacement, first point. The second point here is acceleration is always towards the fixed point. These are the 2 points. Okay, right. Then the motion of the body is called simple harmonic motion. Simple harmonic motion, SHM, is essentially an oscillatory motion, but not all oscillation motions are simple harmonic motion. Do you know? Do you remember this one? The circle, I clearly explained you under the periodic motion. So this is the periodic motion, oscillatory motion, and the simple harmonic motion. Okay, you can watch the first video and take out the note. Okay, can you understand these things? Is it okay? Right. If there are any problem, you can ask me. Okay, right. Okay, so look at the next point. If the force acting on a particle moving in a straight line is always directed toward a fixed point on a straight line, and it's directly proportional to its displacement measured from the fixed point, such a motion is known as simple harmonic motion. These are also the same definition I gave in a different type. Okay, right. So those are the things. So look at the characteristics of the simple harmonic motion. Okay, look at the characteristics of the simple harmonic motion. The first one, the motion is periodic. Is this correct? Yeah, the motion always periodic. The second one, the acceleration of the moving body is proportional to the displacement from the mean position. So there are many wordings for the fixed point. The first one is like, look at the mean position or equilibrium position or fixed point. These 3 wordings are same. Fixed point, okay, or the mean position, fixed point, mean position, and the third one is equilibrium point. Equilibrium point. These 3 words are same. Okay, that means they all together mentioning the first the same point. This is the fixed point, center of the motion. The center of the motion is known as fixed point or the mean position or the equilibrium point. Okay, right. So those are the things in the simple harmonic motion, guys. So take out your exercise book and write down this note now. Write down this note. Note A is equal to minus A omega square sine omega t. A is equal to minus omega square A sine omega t. A is equal to minus omega square x. Okay. Write this equation in your exercise book. These three. Okay. Right. Okay. Right. Okay. Right. So now right. Okay. So uh, please put the heading in your exercise book. Right. Phase. Phase 5. Okay. Right. We are going to study. We are going to study about the phase in simple harmonic motion. Phase. So please okay, please write down the note now. Okay, below this phase, write down the note. Write down the note. Phase simply means. Phase simply means. Phase simply means an angular term. Phase simply means an angular term which represents the state of a particle in simple harmonic motion. Represent the state of a particle in SHM. You can use the short term for the simple harmonic motion, SHM. At a certain instant. At a certain instant. At a certain instant. Write down the second note. Write down the second note. I'll explain you. Okay, right. We calculate the distance of the particle. We calculate the distance of the particle from the mean position. We calculate the distance of the particle from the mean position. During simple harmonic motion. During simple harmonic motion, and convert it into the angular term that is known as the phase. Convert it into the angular term that is known as the phase of simple harmonic motion. Angular term that is known as the phase of SHM. Phase of SHM. Right. Okay, guys. So this is a very important note. Okay, look at this one. So this is also a physical quantity. We should study the first one. We study displacement, amplitude, periodic time, and frequency. This is the fifth one. Okay, you can put the number as well here. This is the fifth one here. Okay, right. Look at this one. This is very simple. This is very simple. Okay, right. Okay, right. So guys, look at this one. We already studied the simple harmonic motion comparing to the projection of the circular motion. Okay, right. So in this motion, can you tell me if the particle is somewhere here now? This is simple harmonic motion, no? This is circular motion. The projection of the circular motion is known as simple harmonic motion. So in this motion, guys, if the particle is here, what about the projection? Projection means when we are giving a light like this to this motion, where will be the where the shadow will be? This shadow is now here. Okay, right. So this is simple harmonic motion. The object now is in a simple harmonic motion between these two amplitude. When it's moving something like this will move like this. I clearly explained you in the first video. Okay, right. Okay, so this is simple harmonic motion and the object is now here. So this is not still, it's not rotated, still not rotated. So the phase of this simple harmonic motion here is 0, guys. Okay, right. It is 0. Okay. Do you know what is the relationship between phi and degrees, like radian and the degrees? Do you know the relationship? What is that? 180 degree is equal to pi radian or 2 pi radian? Pi radian. Okay, right. Can you tell me if this particle rotates an angle something like this, let's say if this is 30 degree, can you tell me the angle in phi? Can you tell me the angle in phi? 30 degree means 180 divided by 6. So 5 divided by 6. So it's 5 by 6, isn't it? So we can write this 30 instead of, we can write 5 by 6 instead of this 30. Okay, right. So now we are the, so now look at this one. So where the simple harmonic motion particle is? Now here. Okay, right. Now here. So now the phase is like phi is equal to pi by 6. Okay. So in this, so look at this one. Why we are using this phi here? What is the reason? Right. Okay. Look at this one. Can you tell me? Right. I'm going to give you some examples on this so you can easily understand. Okay. Right. First of all, try to understand what I'm explaining you right now. What I'm explaining you right now. Okay. Right. When the particle is here now, now tell me what is the angle here? Let's say this is like 120. So if this is 120, can you give me this in radian? Two pi over 3. No, I think. 2 pi by 3. Okay. Sorry. 60 times. Yeah, look at this one. Look at this one. Okay. So what I told you is 100 degree, 120 degree. 120 degree means, so in 180, how many 30s are there? How many 60s are there? 360. So 60 into 3. Look at this one. 60 into 3 is equal to 180. 180. So, but we can, how we can get this one from this 100 degree, 180 degree? What we can do? 180 divided by 360 times 2. Yes, it's equal to 25 by 3. Okay. Yeah, 25 by 3. Is it correct? 25 by 3. So what about 150 degree? Pi over 6. Very good. So you should know that how to convert these angles into radian in measuring instrument. That means the in first unit, in units and dimension, there's a part to convert these radian into degrees. Okay, right. Look at this one. I'm taking like this is like 25 by 3. If this is 25 by 3, look at this one, guys. The object is now here. The object is now here. Okay, right. This is the center equilibrium point. The object is now here. So now the phi is equal to, the phase is equal to 25 by 3. 25 by 3. Okay, right. Look at this one. When the object is now here, when the object is now here, where the SHM particle is now here. So look at this angle. This is phi. The phi is now is equal to, the phase is equal to phi now. Likewise, this is how we are calculating the phi regarding to the circle, the rotation. Okay, right. So what is the, can you tell me what is the difference between this one and this one? First one and the fourth one. So in here, the SHM particle is at the equilibrium point. In here, here's also the SHM particle is in the equilibrium point. So what is the difference between these two? Right. The difference here is, that is why we are using the phase here. Because if someone says like the particle is at the equilibrium point, that means we don't know how many rotations or full rotations or half rotation the particle already completed. We don't know. That is still in the equilibrium point. No, if it is in the equilibrium point, we don't know how many rotation it finished. Right. So that's why we are using the term phi. If we know the phi, we know how many rotation it is already finished. And now where the particle is. You got the point, right? Can you tell me if the phi is equal to, if the phase is equal to 2 phi, what is the meaning of that one? That means the particle completed a full rotation. Okay, right, a full rotation. Now tell me, phi is equal to, let's say, if the phi is equal to 9 phi by 2, how many rotation, where the particle is now? If the particle is, if the particle's phase is 9 phi by 2, where the particle is now? Where the particle is now? Can you tell me? How many full rotation it completed and where the particle is now? Right. I'm going to tell you, this is very easy, guys. Look at this one. This is how you want to calculate this one. Huh? Look at this one. So 9 phi by 2, no? Right. Can you tell me 9 divided by 2 is what? 9 divided by 2 is 4.5. That means 4 plus some fraction is there. You got it? Half of it is there. So what we can, how we can write here is like 4 pi plus pi by 2, because this is 4.5. So 4 means 4 phi plus the 0.5. We can, this is like, if this is 4.5, we can write like 4 plus 0.5, no? That is what I'm writing here. That's all. So 4 pi plus pi by 2. That means what? How many full rotation it completes? 4? No, it's 2. 2 full rotation completed. Why? A full complete rotation is 2 phi. So 2 full rotation, that means 4 phi plus pi by 2. Plus pi by 2 means quarter. Very good. It's quarter. So now the particle is somewhere here. Is somewhere here. Okay, this is 5 by 2. Okay, the particle is somewhere here. So for the SHM particle, we know that it is in the, where the particle is now. It is in the fixed point or amplitude. It is in the positive amplitude. This is, we know, already know that this is positive, no? This is negative amplitude, no? So where the particle is now, the particle is in the positive amplitude. That's all. So this is why we are using the phase. Like, we can also use the distance node. Like, look at this one. Huh? I'm here now. We are measuring all the distance from here, right? If someone says like, I will give the note, okay? Don't write. So after completing it, write it down. So we are measuring the we are measuring all the measurement from this point. This is the fixed point. Let's say if someone says like a particle is in the 3 meter, that means plus 3 meter means the particle is now here. 5 meter means the particle is now here. Likewise, it's going to move, no? Right. So, but we don't know how many rotations it's already completed. So that's why we are using this phase. So now you can read the definition I already gave you. So what I gave you, write down, read the definition. So phi is, the phase we are using to know where the particle is now. Okay, right. So that's why we are using this phi gas here. Okay, right. So what you can do here is, please draw these four uh, diagrams in your exercise book. These four. 1, 2, 3, 4. Okay, right. This is an example. if phi is equal to 9 phi by 2, where the particle is now. Particle is now. Okay, right. So this is the method we want to follow here. Particle is at amplitude. Is in the amplitude. Particle is in the amplitude, right? Write this down. Draw these four diagrams. Draw these four figures in your exercise book and write this down, these examples as well. Write this example as well. This one, if phi is equal to 9 phi by 2, where the particle is now. Okay, right. So in simple harmonic motion, I already told you that we need to draw so many circles here. So it's better to bring your compass or the rulers relevant to draw the circles, or you can bring coins as well. 2 rupee coin. It's hard to find 2 rupee coin, right? Okay, right. So we want to do some questions today. Do you have any doubts? Please let me know. Okay. If you have any doubts, you can ask me. Right. So guys, this simple harmonic motion, you should spend some time to understand. So because all these unit, like this full unit 3 is depend on the simple harmonic motion. If you understood these things, it's easy to understand the rest of the theories. So that's why I'm spending some time in this chapter. Okay, right. Okay, did you wrote this one example? Okay, right, good. So shall I give you another example here? Right, write down the second one. Yeah, the second example is, if phi is equal to, if phi is equal to 6 pi by 4, if phi is equal to 6 pi by 4, 6 pi by 4, how many full rotation, how many full rotation, how many full rotations is the particle complete? How many full rotations the particle complete? Can you tell me how many full rotation it complete? 3? No. How many full rotation it complete? Look at the fraction, 6 pi by 4. So it is equal to, you can simplify this fraction. Tell me, 3 pi by 3 pi by 4. Sorry, 3 pi by 2. 3 pi by 2. This means 1.5 pi. So one full rotation and half rotation. So you can draw as well. So it completed one full rotation. Look at here. Look at this one. Before writing, look at this one. It completes one full rotation and a half rotation. So now the particle is somewhere here. So it is in the fixed point. It is in the fixed point. So the particle is now here. It doesn't mean that it didn't move or it didn't make any displacement, right? So this is 3 pi by 2. The particle is now here. Draw this one as well, right? That's all. That's all. That's enough, I think. Okay, right. Right. I'm erasing this one, guys. Huh? Okay, right. Okay. So write down an exam point. So normally, guys, look at this one. Normally, if a simple harmonic motion happens, we know that it's normally start from the fixed point. It means it start from this point, okay? Right, the fixed point. Here, I don't need to draw the circle here. You want to understand the concept, so that's why we are relating this simple harmonic with the circle to understand the phi, the phase concept. So that's why I'm drawing the circle here. If not, you can do So, right, look at this one. So, if the simple harmonic motion starts from here, if phi is equal to 0, if phi is equal to 0, the equation for the simple harmonic motion like this. So we know, right? The equations are x is equal to, can you say? X is equal to, you should say with me, A sine omega t. What is V? V is equal to A omega cos omega t. What is A? A is equal to minus A omega square sine omega t. So these are the equation if the simple harmonic motion starts from its original point or its mean point or the starting point here, right? Okay, if phi is equal to 0. Guys, there are some simple harmonic motion. It can also start from, there's no laws that it want to start from here. It can be start from here also, right? The motion can start from any points, right? It can start from any points. Look at this one. Let's say the motion is somewhere starting from here. Now the motion is starting from here. Let's say this is, let's say the phase is phi now. Let's say the phase is phi now. Okay, right. So we know that these are the amplitudes. This is the fixed point and the particle is now here. So the simple harmonic motion now starts from this point. Okay, right. If the simple harmonic motion starts from this point, can you guess the equation now? Can you guess the equation while looking at this one? Right. If, look at this one now. If phi is equal to, let's say, if phi is equal to, if the phase is, look at, if the simple harmonic motion, if the simple harmonic motion starts from phi, starts from phase phi, starts from phase phi, guys, the equation looks like this. X is equal to A sine omega t plus phi. Omega t plus phi. We need to add this angle. You got it? So because let's say guys, so if we take this, if we write down this equation something like this, look at this one. X is equal to A sine theta. Let's say x is equal to A sine theta. If theta is equal to 0, where the object is now, where the particle is now. Theta is equal to 0 means the particle is now here, no? You got it? Here, no? Right. Now, what is the angle this particle turn into? The angle phi, it's already turned. But from this point, there's no any angle. It doesn't make any angle here. You got the point? It is starting from this point, guys, but it doesn't move any angle. It's something like this. You can imagine something like this. If this is 30 degree, if this is 30 degree, guys, okay, let's say this is like 10 degree. Okay, if this is 10 degree, now what I'm telling here is the particle is now something like this. It's already displaced the angle 10 degree here. Now what I'm telling here is now it makes 30 degree. That means from this point, this is making 30 degree. Okay. So what is the angle you will substitute in this equation? What is the angle you can substitute in this equation now? 10 or 30 or 40? 40. because we are always measuring the equation from here. Okay, so the angle now here is, guys, 40. It's not 30 here. So what we are doing here is we are adding that 10 with the 30. So that's why what I'm saying here is, what we want to do here is, for the omega t is already theta, no? So if this is theta plus phi, if the phi is equal to 0, that means it is starting from this point. Okay, if there is any phi, you should substitute here. You should substitute here. So we can write down now. So we can write down the equation. So what we are doing here is, if there is a initial phase, we should add that in the equation. So V is equal to A omega cos omega t plus phi. A is equal to minus A omega square sine omega t plus phi. Okay, right. Can you guess if the particle start its journey from this point? The particle is now here. The particle is now moving like this. The starting point is now here. Now, can you tell me what is the equation should be? X is equal to A sine omega t minus phi. Why minus phi? Because from this point, already some angles here, it turns. So we should mention that one also. So, right? So that's why we want to put minus here. You got the point. So let's write this down in the special point. Okay, special point. Special. Okay, right. Okay, so that's all. So what we are doing, what we are going to write here is, write down the exam point and write this down. Okay. Exam point and write these two, and this is the special point. For this one, you can write down the equations. X is equal to A sine omega t minus phi. B is equal to A omega cos omega t minus phi. Cos omega t minus phi. A is equal to minus A omega square sine omega t minus phi. Okay, write this down in the exam point. First, write this down. Second, write this one. And it's a special point. If someone asks something like this, you can use these equations. if phi is equal to 0, the equations are normal. X is equal to a sin omega t, v is equal to a omega cos omega t, a is equal to minus a omega square sin omega t. If the phi is a positive value, the equations are x is equal to a sin omega t plus phi, v is equal to a omega cos omega t plus phi, a is equal to minus a omega square sin omega t plus phi. If the phi is minus value, if the phi is in the minus values, that means the particle starts its journey from somewhere here. Somewhere here, the equations are like x is equal to a sine omega t minus phi, v is equal to a omega cos omega t minus phi, a is equal to minus a omega square sine omega t minus phi. Okay, right. So let's do some problems now. Okay, right. Take out your homework sheets. Did you finish writing? You completed? Write it down. You got the tudes? You got the tude? Check out the homework sheet, right? Right. Look at the first question. So the heading in your exercise book, homework sheet discussion. Homework sheet discussion. So we are going to discuss the question number 1. Okay, right. Question number 1. First question, the first one. What is simple harmonic motion, and give some examples. So we already wrote the definitions and everything there. So that is in your theory note. Okay, right. So you can write it down. The second one. Okay, the second question. That is already in the tube, right? Okay. So look at the second one. Define simple harmonic motion and derive the characteristic equation. You should derive the equation. A is equal to minus omega square x equation. Using these equation, we already derived those equation in the tube. I already gave you. Okay, right. So we consider the projection of the circular motion, and we derive the equation A is equal to minus omega square x. Okay, right. Let's move on. The third one. Okay, look at the third question. Third question. Define the terms periodic time, frequency, and amplitude of a particle executing in simple harmonic motion. Okay, right. These also we studied. What is periodic time, frequency, and amplitude? The definition are given already. So this is in your note. Okay, right. Look at the fourth one. Look at the fourth one, guys. Okay, right. That is all. Draw the displacement time function of a particle engaging in simple harmonic motion. For this one, for the graph things, we will study this one. We will study this one. For the graph, the next, after completing this question, I'm going to move to the graph section. Okay, right. Look at the fifth question, right? Find the periodic time and frequency of a motion which has the characteristics equation A is equal to, look at this one, A is equal to minus 25x. Right, look at this one. This is very important, right? If we saw an equation A is equal to minus 25x, we can relate this equation to which equation? A is equal to minus omega square x equation. We can relate this equation to A is equal to minus omega square x equation, guys. So the A is here, minus is here, x is here. So now tell me, what is the value for the omega square? Omega square is equal to 25. That's all. It's very simple, right? So omega square is equal to 25. 25. Now tell me, what is omega, guys? Omega is equal to 5. What is the units of the omega? Radian second minus 1. Radian per second. Radian second minus 1. Okay, right. So this is the, now we know the angular velocity of this motion. Okay, what they are asking here, find the periodic time. Guys, look at this one. If we know the omega, how to find the periodic time? So there is an equation here. T is equal to, okay, T is equal to 2 phi over omega. T is equal to 2 phi over omega. Look at this one. Normally in circular motion, in mechanics, in circular motion, you will study this equation. Okay, right. Normally that is in the circular motion. Okay, right. Look at this one. Look at this one. Don't write anything. Right. We can prove this one as well. Okay, right. Look at this one. This is the circle. If we want to complete a full rotation, if you want to complete a full rotation here to the board, so now the projection of the particle is now here, the projection is also here. We know that when the particles complete a full rotation, this particle will move like this. This is a full oscillation. You got it? The particle is now here. So when we are bring a light towards this direction downwards, the shadow of this object is now here. So when it's moving something like this, it will move like this. So to complete a full rotation, this will take, let's say, this will take capital T time. What about this one? What is the time this will take? If the particle take capital T time to complete a full rotation, what about this particle to complete a full oscillation? What is the time taken? That is also T. Because of why? Because both are happening in the same instant of time, no? Both are same, right? So this is also T. So this is a full oscillation we studied. Going here, come back to fixed point, and going to minus amplitude, come back to fixed point. So this is a full oscillation. So it is moving in a simple harmonic motion. This is rotating. So a full rotation is completing here. And also, here also a full rotation, a full oscillation is completing. Okay, both time period are T. Right. Can you tell me what is omega? The first class I teach you. What is omega? Omega is equal to theta by T. What is velocity normally? Velocity is equal to displacement over time. So here, omega is angular velocity. Angular velocity is equal to, tell me, angular displacement divided by time. Okay, normally velocity is equal to displacement time. This is angular velocity is equal to angular displacement divided by time. Angular displacement we measure with theta. So theta divided by t. So this is the equation, guys. Okay, so this equation I'm going to substitute this equation for this motion. Now tell me here, omega is equal to, for the full rotation, what is the angular displacement? 2 phi. For the full rotation, the angular displacement is 2 phi divided by, what is the time taken to complete a full rotation? Capital T. So with this one, T is equal to 2 phi over omega. Now you understood, right? Okay. So this is the equation, T is equal to 2 phi omega. Right. So we know the omega. How to find the T now? T is equal to 5 omega. Let's substitute. Yeah, T is equal to 2 phi. This is a constant, okay? 2 phi divided by omega. The omega is 5 here. Can you tell me the units of the 2 phi? It is in the radian. Okay, it is in the radian. 5 radian per second. When we cancel these two, second minus 1 coming, so it's second. So tell me how many seconds? So can you please multiply up and down here? So 4 pi 10. 4 pi divided by 10 is 0.45. Okay. 0.45 seconds. What you can substitute for this 5? What is the value for the 5? What is that? 22 divided by 7. Okay, 22 divided by 7. If you want to get the numerical value for this, you can substitute 22 divided by 7 in this equation. Okay, so now we found the time period t. So you should know the relationship between the t and omega. What is the relationship between the t and omega? T is equal to 2 phi over omega. So this is the relationship between t and omega here, guys. Okay, right. So this is the answer for the t. Okay, right, the t. So when you substitute the value here, 0.4 into 22 divided by 7, you will get the answer 1.265. 1.265 seconds. Okay, right. So this is t. What about the next question? Let's, yeah. They are asking for the frequency as well. They are asking for the frequency as well, right? So here, how we found the omega and the t here. The second one is frequency. What is the relationship between the frequency and the time period, periodic time? Very good. F is equal to 1 over t. F is equal to 1 over t. So here, what we can do here is 1 divided by, you can substitute the value here for the t. It's 1.265. 1.265. So you can get the value here, guys, like 0.8. What is the unit for the frequency? It's hertz. Okay, 0.5 hertz. Okay, this is the answer. So please write this down in your exercise book. Yeah. Sorry, why can't we take phi as 180 degree? We are not substituting here with degrees. We are substituting here with the radian value. So in radian values, normally, do you know what is phi? I think Pentalians know more than me about the phi. So like, look at this one. Huh? You got it? Okay, right. If I explain that those things, like I need to draw a circle and do all the things, right? Okay, write it down. Write it down. Guys, this is the summary note. Huh? This is also the note, right? The following note. Okay, exam point. Don't substitute 180 degree here. Okay, right. So you can here the radians are cancelled. So the phi, the value is like 3.14, right? So 22 by 7, no. So we can't substitute the degrees here, because if you want to substitute the degree for phi radian only, we can substitute the degree. For the phi only, the value, no. The phi means the value, no. The 22 divided by 7, no. This radian is cancelled here. So we want to substitute only the value here. So write this down in your exercise book. Okay, I'm going to erase this one. At first, this unit looks like this. After completing this simple harmonic motion, you can get a good knowledge how these particles are working, or how these waves are forming and how the particles are moving. Everything you can clearly understand. Can clearly understand those things. Okay, right. We round this value, right? So you know the meaning of this one, right? Okay, right. I round the value, not the exact value. Okay. Okay, right. Look at the sixth question. Look at the sixth one. Look at the question number 6. Question number 6. Okay, right. Look at the question number 6. Find the periodic time and the frequency of the motion which follows the characteristic equation A is equal to minus 16 phi square into. Look at the equation. There is a small error in the equation. Look at this one. A is equal to minus 16. Okay, A is equal to minus 16 phi square minus 16 phi square into 10 to the power 4y. 10 to the power. This is not x. This is into 10 to the power 4y. So how you can relate this equation with A is equal to minus omega square x? Can you tell me? Right. So look at this one. A is equal to minus omega square x. Okay, right. So here for the x displacement in this equation, they are using y. There's no problem with using x and the y and the z. There's no problem because here they took the x-axis, here they took the y-axis. That's all. Only the x and y, those represent the displacement only here. Okay. Look at the rest of the equation. Here, this one, no, this one. So now, can you tell me omega square is equal to what? Omega square is equal to what? 16 5 square into 10 to the power 4. So now tell me what is omega is equal to? Very good. 4 pi, you can take the square root here. So into 100. Omega is equal to 405. So now try to find the T and F. Now try to find the T and F. Okay, right. It's very easy. What is the relationship between the T and the omega? T is equal to 5 over omega. So try to find the T and the omega. Sorry, T and the F. X, Y both are displacement. Okay. What is T, guys? T is equal to 5 omega. So 25 divided by 405. What's the value? Sorry? For the T, what's the value? Don't look at the answers. Okay. Don't look at the answers, huh? Those answers are incorrect. I think there's a typing mistake. That's why. What is the value, guys? T is equal to 25 over omega. So I'm going to substitute here. T is equal to 25 over omega. So T is equal to 25 divided by 405. So 5 cancel, 1 divided by 200. 1 divided by 200 seconds. 1 divided by 200 seconds. Okay, right. Look at the next one. So we want to find the frequency. Frequency is equal to 1 over T. So frequency is equal to 1 divided by T is 1 divided by 200 is equal to 200 hertz. Okay, correct. Is this correct? Yeah, good. Okay. Sorry? 1 divided by 1 over 200. So this came up, no? Sorry? 1 over, yeah, 1 over 200. No, for this question, if you need, you can simplify this one, but you don't need, right? Okay, right. If you want to simplify this one, this is like you can divide this by half. So here we can divide by 2, divide by 2. This is half, like 0.5. Here this is 100. 0.5 divided by 100, it's like 0.005. Okay, right. You don't need, sometimes that is dependent on the question. Okay, right. For this question, this is enough. Okay, right. I'm going to give you some examples here. Okay, right. If, write down, first example, if omega is equal to, if omega is equal to, if omega is equal to 2 radian second minus 1, if omega is equal to 2 radian second minus 1, 2 radian second minus 1, Derive the equation for the simple harmonic motion. Derive the equation for the simple harmonic motion. Derive the equation for the simple harmonic motion. Okay, right. If omega is equal to 2 radians second minus 1, derive the equation for the simple harmonic motion. Can anyone get the answer? Who got the answer for this one? Derive the equation for the simple harmonic motion. Normally tell me what is the equation for the simple harmonic motion? A is equal to minus omega square x. So what is the equation here? It's very simple, right? Look at this one, guys. If omega is equal to 2 radian second minus 1, what is omega square is equal to? 4, very good. It's 4. It's 4 radian. It's 4. We don't need the units here. It's like radian square second minus 2. So omega square is equal to 4 here. So directly we can write it down. Minus omega square x. So the equation here is A is equal to, for the omega square, we can substitute 4x. You got it? So equation here is A is equal to minus 4x. Write on the second example. If t is equal to 6 pi seconds, what is t? Periodic time, okay? Right. If t is equal to 6 pi seconds, find the omega and derive the SHM equation. Find the omega and derive the SHM equation. Tell me the answer, guys. Tell me the answer now. You should be quick, huh? Right. If t is equal to 6 pi seconds, find the omega and derive the equation for the simple harmonic motion. Once if you find the omega, you can write down the equation. Simple. T is equal to 2 pi omega. So omega is equal to 2 pi over t. Got the answer? What is omega? Sorry, 1 over 3 radian second minus 1. Very good. What about the equation? A is equal to minus 1 over 9 x. Very good. That's the answer. So here 2 pi divided by 6.5. Can cancel this one, 1 by 3. So radian per second. Okay, right. So using this one, so you can directly write down the equation. You can directly write the equation minus omega square x. So 1 by 9 x. So this is the answer. Okay, right. So now I think let's do one more problem. Fourth one, sorry, third one, no? Right. If f is equal to, if f is equal to 1 over 100 pi. If f is equal to 1 over 100 pi hertz, find the t, comma omega. Find the t, comma omega. Derive the equation for the SHM. Derive the equation for the SHM. Derive the equation for the SHM. Okay. You got it? What's the answer for the t? Sorry, 105. That's when you are looking at the equation f is equal to 1 over 105. We know that f is equal to 1 over t, you know. So the t is should be 105. That's all. So the t is here 105 seconds. Right. What's the next one? Omega. Yeah. What is the equation for the omega? Omega is equal to 25 over t. We can write another equation as well. Look at this one. Omega is equal to 25 over t, right? Sorry, 25 over t, right? Okay, 25 over t. What about this one? What about this one? Omega is equal to 25 into 1 over t, right? So you can write omega is equal to 25 into, for 1 over t, what can we substitute? F. So omega is equal to 25 f. Omega is equal to 25 f. So this is also note. So you should remember this one. You should highlight this one. Okay, right. Again, so we can substitute the f here. So omega is equal to 25 into f. The value for the f is like 1 over 105. So 25 into 1 over 105. So cancel 1 divided by 50. Is it correct? 1 over 50 radian per second. Okay, right. So what's the equation, guys? What's the equation for the simple harmonic motion? A is equal to minus omega square. What's the value for the omega square? 1 over 250? 2500, right? Okay. 2500, isn't it? Okay. So 2500 into x. That's all. A is equal to minus omega square. Yeah. Here, if you use decimals, is it okay? No worries. It's fine. So what we can use here, like 4, you can, yeah, 4, 0. It's like you can multiply both up and down 4. So 4 divided by, it's like 10,000. So you can get the values there. Okay. You can write this down like this as well. Right. A is equal to minus 4 into 10 to the power minus 4x. Is it correct? You got it? So you can multiply 1 by 4, 1 into 4 is 4, 2500 into 4. What's the value? It's 10,000. 10,000 means 1 into 10 to the power 4. When it's coming up, it's like 10 into minus 10 to the power minus 4. So minus 4 times 10 to the power minus 4 into x. Okay, right. This is also fine. You can use decimal as well. So that is depend on the question, right? Sometimes they will give the answer. So in the MCQs, if there's MCQ, you can find out the answer. No worries. Okay, right. So for the graph question, we'll go for that later. And okay, that's all. You have any doubts? Guys, if you have any doubts, you can call me and you can ask me anytime, no worries, okay? So I can be there for you to explain everything. Don't leave the class without understanding. That's the main thing, okay? Right, that's all. So now you have an idea, right? So now you have an idea how to solve problems and how to do problems on this simple harmonic motion, okay? Right. So now what I'm going to do here is I'm going to move to the graphs, okay? I'm going to move to the graphs now. Okay, put the heading in your exercise book, put the heading, graphs in simple harmonic motion. Graphs in simple harmonic motion. Okay, right. So can you tell me how many in linear motion, what are the basic graphs we have? ST graph, VT graph, and AT graph. Sometimes FT graph as well. So we'll study FT graph in Newton's laws of motion 2.3. Did you study? What is the area of the FT graph? What is the area of the FT graph? You don't know? Area of the FT graph is change in momentum. Can you remember? Ah, right. Now only the bulb is blinking. Right? Okay, we studied that's one, right? Okay, so that's why the revision is very important. Okay, right. Okay, graphs in simple harmonic motion. So before going for this graph, what I'm going to do here is I'm going to explain you about the relationship between the periodic time and the phase. Okay, right. You already studied these things. Then look at this one. Okay. If you forget something in simple harmonic motion, simply you can draw a circle and you can compare with the projection of a circular motion with the simple harmonic motion. It's very easy, right? Okay, right. So now I didn't forget anything, just I'm writing this one to explain you, right? Okay, so now tell me, if the particle is now here, the projection is now here. If the particle is here, the projection is here. If the particle here, projection is here, the particle is here, the projection is here. Okay, like for a a complete rotation, the time taken is capital T. Okay, this is a simple harmonic motion. For a full oscillation, it will goes like this, come back to the fixed point, go to this point, come back fixed point. Okay, right. Can you tell me in t by if in t is equal to naught, in t is equal to naught, what about the phase? What about the phase in t is equal to naught? The phase is also theta is equal to naught here. Theta is equal to naught here. Okay, I'm going to write theta is equal to naught. Okay, right. If t is equal to, let's say this is simple t. If t is equal to t by 4, what about the theta? T by 4 means for a full complete oscillation, the time taken here is capital T. For the quarter, going here, T by 4, T by 4, T by 4, T by 4. If T by 4 is 1 second, like 1 second, 1 second, 1 second, 1 second. Totally, the time period is 4 seconds. Okay, right. So if T is equal to, if T is equal to T by 4, what about the theta? What is the angular displacement? In T by 4, the object is here, no? So here it's 5 by 2. Very good. It's 5 by 2. 2t by 4. T by 4. Again, what I'm going to do here is 2t by 4. 2t by 4. 2t by 4 is equal to what? 2t by 4 is equal to t by 2. 2t by 4 is equal to t by 2, right? Okay. So when the object is here, when it's coming back, it's t by 2, right? So I can write down like this, t by 2. So in time period of t by 2, the object is now here. The angle is theta is equal to 5. T is equal to now 3t by 4. In 3t by 4 time period, the object is now here. So now the angle is like this. What about the angle now? Pi by 2, pi by 2, pi by 2. It's 3 pi by 2. Very good. Theta is equal to 3 pi by 2. If t is equal to capital T, that means 4t by 4 is capital T. So capital T, what about the theta? 4 pi by 2. 4 pi by 2 is what? Complete rotation is 2 pi. So first of all, we should know about this time period and the relationship between the time period and the phase. Okay, this is the relationship between the time period and the phase, guys. Okay, right. So now let's move to the graphs. Number one, we are going to study about the first graph. First graph is displacement time graph. Displacement time graph. So you can say like xt graph of a simple harmonic motion. Xt graph of a simple harmonic motion. Okay, right. So in this graph, guys, in this graph, I'm going to draw this graph. You all studied about the sine, costan, graphs in maths, IOL maths. Okay. Sometimes there will be some biology students as well in the online also. Okay, right. Look at this one. So this is xt graph, guys. This is the axis. What is the relationship? Now tell me, what is the equation for the displacement of a simple harmonic motion? Tell me, x is equal to a sine omega t, or we can use x is equal to a sine theta, isn't it? Yeah. Look at the equation. X is equal to a sine theta. A sine theta. Okay, right. Now, what I'm going to do here is, with the time period, I'm going to plot the graph. Look at this one. So this is like t by, this is 0. The time is 0 here, 0. This is t by 4, t by 4. Right. This is t by 4. This is 2t by 4. What is 2t by 4? T by 2. Okay. T by 4. 2 times t by 4, right? That is 2t by 4 is t by 2. This is what? 3t by 4. Okay. I'm getting the scale like this. 3t by 4. This is what? 4t by 4. 4t by 4 is equal to t. This is 5t by 4. This is 6t by 4 is equal to 3t by 2. 3t by 2. This is 7t by 4. Okay. This is the time. Okay. This is the time. For this, instead of time, I'm going to put the angle as well in this axis. Okay. I'm going to put the angle also, phase also here in this axis. So here in the top part, I'm going to put the angle here, right? For the 0 time period, the theta is also 0. T by 4, the angle is also pi by 2. This is pi by 2. This is 2 pi by 2 is 5. It's 3 pi by 2. 4 pi by 2 here. This is 4 pi by 2 means 2, 5. This is 5 pi by 2. This is 6 pi by 2 is 3 pi. This is 7 pi by 2. So this graph is belongs to xt and x theta also. Because for this, instead of time, I taken the phi also. You can draw this graph for the t and theta also. You got this? You got this same graph for both, right? Okay. So what I'm going to do here is I'm going to substitute the values for the sine here. Okay, right. Now tell me in t by 4 time period, the phase is like 5 by 2, no, the angle is 5 by 2, no, right. Substitute the 5 by 2 for the theta. Sine 5 by 2, sine 90, what's the value? Sine 90, what's the value? It's 1. Yeah, it's 1. So x is equal to plus a. Sine 90 is positive 1, no? So x is equal to plus a. X is equal to plus a. Before that one, what about this one? The t is equal to node, the angle is theta is equal to 0. So sine 0 is equal to what? 0. So x is equal to a into 0. The value is 0. So this is the point. So this is the first point. In pi by 2, the value for the sine is sine 90 is equal to 1, positive 1. So x is equal to plus a. So look at this one. In 5 by 2, it's positive a. So this is positive a. What about sine pi? Sine pi is equal to sine 180 degree is equal to 0. Right. So if it is 0, x is equal to 0. X is equal to 0. What about sine 3 pi by 2? 3 pi by 2. Sine 270 degree. What's the value? It's minus 1. It's minus 1. So if you put minus 1 for this sine theta, it's x is equal to minus a. So this is minus a. So can you identify the pattern? Can you identify the pattern here? 0, plus 1, 0, minus 1. Again, for the 2, 5, 0, 0, plus 1, 0, minus 1. So how to draw the curve now? How can we draw the curve now? So the sine curve. So the sine curve, it looks like this. So this is the displacement time graph for the simple harmonic motion. This is the displacement time graph for the simple harmonic motion. Okay, right. So, right. Can you tell me if theta is equal to 0, what about the displacement is also 0? That means, what about the fixed point? In fixed point, the displacement is what? 0. Because the fixed point x is equal to 0, no? Right. In the fixed point, the displacement is 0. What about the amplitude point? The highest displacement point. The displacement is maximum. What is the maximum value of the displacement? Plus A, O minus A. If you took the, only if you took the magnitudes of this displacement, it is A. So magnitude means there's no direction plus or minus. So the maximum displacement is amplitude. So here in the maximum displacement point, the value is plus A and minus A. So this is the graph for the displacement type, XT graph for the simple harmonic motion. Okay, right. So you can write this down. After put the heading here, graphs in SHM, draw this one and draw this graph. Okay, right, in your exercise book. Are you all free on Mondays? No? Today, sorry? Do you have classes? You have practice, chess? Then? Okay. So let's talk with, sorry? If we shift the class to Tuesday, they can come. What about you? Mondays. That's Tuesday is possible, right? Okay, okay, I'll discuss with the management and I'll let you know before the class. Okay, right. Draw the graph. For this, for today's chapter, I didn't give you the tune because of you should draw these things in okay, in your hand. So the practice is important. So that's why I didn't give you the tunes for today's session. So some of the students are asking, like Kandy students are asking, to visit my physical class. I think if you visit physical class, it's like monthly it's 2,500 only. Okay, for the physical. For the online, it's 3,500. So it's better to follow up in the physical class. Kandy students, you can follow the physical classes. Okay, right. Okay. So I think, yeah. So this unit is a very simple unit. Without understanding the simple harmonic motion, you can't do anything. That's the main problem here. So it will take some time. So you should be patient and should be focused on the concept and you practice the two questions. And it's easy to get good results in your finals. The first class I told you, right? So 20 marks is coming from this unit only. So it's a very important unit. This is the second main unit. What is the first main unit? Mechanics. After mechanics, this is the second main unit. The third one is like the heat. The fourth one is electricity. Okay. That is also an important unit. I'm planning to do unit 1 and unit 2 revisions on Mondays. Online is okay. Is it okay? Online? Yeah, we can start the revision in online, I think. I'll try to shift the classes to Tuesdays, okay? If it is okay for you, I can shift it. No worries. It's displacement time graph. Okay. Okay, right. Shall we move to the next one? I hold on. Okay, right. So okay, so here you can substitute like this as well. Look at this equation. So we know that x is equal to a sine omega t, no guys? A sine omega t, no? For the t, what we can substitute here? For the t here, we want to substitute, right? For the t values, we want to substitute here. Like the t is equal to t by 4, t by 2, 3, t by 4, t, 5, t by 4. Likewise, we want to substitute here. Look at this one. Look at the board. Okay, right. So we want to, for the t, we want to substitute here. When we are when we substitute t is equal to like t by 4, t by 4. So now what we want to do? What is the next step? So how can we calculate the sign values here? It's hard, no? Look at this one. Can you tell me what is omega is equal to? T is equal to 2 pi omega. T, omega is equal to 2 pi over T. 2 pi over T. So now look at this one. X is equal to a sine omega. For the omega, we can substitute 2 pi over capital T into simple t. For the simple t value, we want to substitute here t by 4, t by 2, 3t by 4, t, 5t by 4 values. When we substitute t by 4 here, what's the value? Tell me. When we substitute for the t, when we substitute the t by 4 here, so this is t by 4. T cancel. 4 is here. 2, 5 divided by 4 is 5 by 2 is 90. You got it? So from this equation also, you can go for the 5 by 2. From this equation also, you can go for the 5 by 2. So this is the method. So you can write this down, this one also. Okay. Right. If t is equal to t by 4, if t is equal to t by 4, x is equal to sine, a sine to 5 by t into t by 4. So x is equal to a sine 5 by 2. X is equal to a sine 5 by 2. I'm writing here. That's not clear. If t is equal to t by 4, x is equal to a sine 2 phi by t into t by 4. So x is equal to a sine 5 by 2. So x is equal to a plus a. Okay, right. So that is a displacement time graph. So let's move on. Let's move to the next one. The second graph is the second graph is velocity time graph. Velocity time graph, VT graph. VT graph. Yeah, sure. Sure. You don't need to ask, you can go. Okay, right. So look at this one. Look at this one. So when you are drawing the VT graph, so let's plot the axis. Let's put the axis. Okay, right this. So this is t by 4, 2t by 4, 3t, 4, 5, 6, 7. Okay. 2t by 4 is equal to t by 2, 3t by 4, 4t by 4, t, no? 5t by 4, 6t by 4 is equal to 3t by 2, 6t by 4, 7t by 4. Okay, right. So let's write down the angle phase angle related to this time period. So 5 by 2, 2 pi by 2 is 5, 3 pi by 2, 4 pi by 2 is 2 pi, 5 pi by 2, 6 pi by 2 is 3 pi, 7 pi by 2. Okay, right. This is VT graph, right? VT graph. What is the equation for the velocity? V is equal to A omega cos omega t. Very good. V is equal to A omega cos omega t, or we know cos theta. This is the equation. So V is equal to A omega cos omega t. We are considering these VT graphs are starting from phi is equal to naught. If this is starting from phi is equal to some values, we want to add that one here also. You got it? Omega t is plus phi, no? Right. Okay. So now tell me how to draw the graph now. Okay. Right. Let's substitute. What about 0? Cos 0 is equal to 1. Yeah. 0 is equal to 1. If you substitute positive 1 here, V is equal to plus A omega. Right. So this is plus A omega. Plus A omega. The point is here. What about cos phi by 2, cos 90 degree? 0. What about cos phi is minus 1. So now you know the pattern, how it will be. Plus 1, 0, minus 1, 0, plus 1, 0, minus 1, 0, plus 1. So this will be, looks like this. Okay. This is the graph for the velocity time. Okay, right. Yes, a omega is the highest value for the velocity. Okay, right. What about the minimum value? Is minus a omega. This is not minimum value. This is not the minimum value. We are considering the magnitudes only. Yeah, the minimum is 0. Okay, right. So here, I'll give you a point later. Here also, I'm going to mention here, what is the V minimum value? V minimum value. The V minimum value is here is 0. What is the V maximum value? V maximum value. Consider magnitude only A omega. A omega. For here, what is the X minimum? X minimum is equal to 0. What about the X maximum? A, very good. That's all. You can write this down. Okay, right. So in which points the velocity is maximum? In which points? No, I'm asking in which points, the fixed point or the amplitude? Yeah, very good. So the amplitude, sorry, not the amplitude. Look at here. So amplitude means this is the fixed point, no? The phi is equal to 0 means fixed point. Theta is equal to 0 means fixed point. So the fixed point, the velocity is maximum. So in this graph, velocity time graph, the fixed point, the velocity is maximum. What about the amplitudes? Velocity is 0, right? But in displacement time graph, in the fixed point, displacement is 0. In the amplitude, the displacement is maximum. Okay, that's all. Right, for you both. Look at this one. So this is like velocity time graph. In this velocity time graph, I took the same time, the same theta value. Okay, right. What is the equation for the velocity? V is equal to a omega cos theta or a omega cos omega t. Okay, right. So what we can do here is we can substitute the values here. Right. Let's substitute the angle 0 here. Cos 0 is equal to positive 1. So 1 means V is equal to a omega. This is 1, no? So V is equal to a omega. So here, if the theta is 0, V is equal to plus a omega. Cos pi by 2, cos 90 degrees is equal to what? 0. Cos 90 degrees is equal to 0. Sin 90 is what? 1. Cos 90 is 0. So cos 90 is equal to 0. A omega into 0, the velocity is 0 here. 0. And when you substitute phi here, cos phi is minus 1. So if it is minus 1, the value is minus a omega. So you can track the pattern plus 1, 0, minus 1, 0, plus 1, 0, minus 1, 0. So you can plot the cos graph here. Okay, right. Look at this one. So this is which point? If x is equal to, that means if theta is equal to not mean what? That is in the fixed point, no? Fixed point. In fixed point, the velocity is what? A omega. So in the fixed point, the velocity is maximum now. You got the point? In the fixed point, the velocity is maximum. In the fixed point, what about the displacement? 0. So in the fixed point, velocity is maximum, displacement is 0. In the amplitude, amplitude means phi by 2, no? In the phi by 2, look at the velocity is what? 0. In the amplitude, velocity is 0, displacement is maximum. So here, V minimum is equal to here 0. V maximum is equal to what? A omega. In this graph, X minimum is equal to 0. X maximum is equal to what? A. So there are two values, no? Plus A and minus A. So look at this one. If this is plus A, this is minus A, no? So this is maximum and this is minimum, no? So why can't we say this is minimum? We are only considering the magnitudes. not the direction here. Okay, right, that's why. Okay, so you should remember at the fixed point, displacement is 0, velocity is maximum. At the amplitude, displacement is maximum, velocity is 0, right? Please note this one. Please note this one also. Please note this one also under your first graph. And now you can write this down. You finished? Okay, good. Can you guys please try to draw the graph for the AT graph? Please give a try in the rough sheet, not in the notebook. Give a try to draw the AT graph, acceleration time graph for the simple harmonic motion. In the notebook, in the rough sheets, give a try. Okay. You all guys know the values for the sine cosine values, right? Okay. Math students should remember, right? Okay. I think most probably for next week, I will try to shift the class on Tuesdays. Okay. I'll give a try. try to draw the graph for acceleration time, A versus T, AT graph. So, you know the equation A is equal to minus A omega square sine omega T. So don't forget the minus here. Okay, right. This is something looks like the triangular graph, right? This is not a curved line. These are straight lines. It should be curved. Okay. Okay. Right. So this is how we can draw. Look at the third one. Acceleration time graph. Okay, right. Acceleration time graph. So look at this, guys. So in acceleration time graph, let's write the, let's put the x-axis values. So this is like, you know that t by 4, 2t by 4, it's t by 2, 3t by 4, 4t, 3t by 2, and 7t by 4. What about the pi by 2 by 4 pi by 3 pi? So now, so look at the equation. So we know that A is equal, look at the board, guys. So A is equal to what's the value? Minus A omega square minus A omega square sine theta, sine theta. So this is the equation. So this is the equation for the acceleration. Right. Let's mark the values. So look at here. So if sine theta is equal to naught, we know that A is equal to naught. A is equal to naught. Okay, right. A is equal to naught. If sine pi by 2, sine 90 is plus 1. So plus 1 into minus A omega square is minus A omega square. So this is minus A omega square. Sin is equal to 0. Sin 3 pi by 2 is equal to minus 1. Minus 1 into minus a omega square is equal to plus a omega square. Plus a omega square. So you can draw like this. Okay. Okay, right. So can plot the graph, something like this. Right. Now tell me what is the maximum value for A maximum is equal to what, guys? A maximum. Oh, tell me the A minimum. A minimum is equal to what? 0. Acceleration minimum is equal to 0. What about maximum acceleration? A max. Consider the magnitude only. A omega square. Very good. Very good. A omega square. So you all understood what's happening here. Okay, right. That's all. Draw this one. You have any? Yeah, tell me. Sorry? Minimum is not minus, right? The reason here is we are only considering the magnitudes, not the direction. So when we are not considering the magnitudes, sorry, when we are not considering the directions, plus minus is, there's no plus minus. So only look at the values, a omega square, a omega square. So the value wise, it is a omega square. The minimum is 0, not minus. Okay, that's why I will already discuss one. Okay, right. I already discussed that one in the previous session. Okay, right. So these are the three graphs of simple harmonic motion. These are the important three graphs. Okay, and also there's also one more graph as well. Let's draw that one also. Finishing these graphs, we have to prove some, we want to prove and get the equation for the periodic time for the simple harmonic motion, spring mass system, and floating cylinder in the water. For those systems, we want to derive the equation for the periodic time. After completing this one, we'll move to that one. Okay, right. Now, next class, we will discuss those part. In the next week, we are finishing the theory part and we will move to the next topic, 3.2. Like was the graph, okay? And then we want to find out the periodic time as well here. This is T by 4, we know, right? So if you know the T by 4 value, we can find the T. If you know the T, we want to find out the omega. If you know the omega, we can write the equation for the simple harmonic motion. Likewise, the question can be done. Okay, right. So there are several questions are there. Sometimes they will give us the graph. Sometimes they will, we want to draw the graph for the simple harmonic motion. That is dependent. Okay, that is dependent. So we'll do more questions on that one. Okay, right. So here I'm doing the revision and theory part, both. Okay, after completing one chapter, I will do past paper questions as well. So the MCQ I gave you, right? Those questions are past papers. Those questions are past paper questions. So when you are doing after completing each and every chapter, when we are discussing the past paper questions, we know that in final examination, how the questions are coming. We studied one chapter, we completed this chapter now. After completing this chapter, we should know that, are we able to do the problems? We should know that, no? Right. So how can we can do or not while doing past papers? Okay, right, very good. Right. So I'm going to do the summary now. Look at this one. So look at this one, huh? Right. First of all, now tell me in the fixed point, displacement is equal to maximum or minimum? Minimum. Yeah, minimum. X minimum is equal to what? 0. In the fixed point, X minimum is equal to 0. What is the X maximum value? Here the maximum is plus A. Here X minimum, sorry, X maximum in the right side direction. So this is like minus A. In fixed point, velocity is maximum or minimum? Velocity is maximum or minimum? Maximum, yes. Fixed point, velocity is maximum is equal to, what is the maximum value? A omega, right? So the maximum value is A omega. The equation is A omega cos theta, theta. So look at the graph. Look at the graph. So theta is equal to 0. If theta is equal to 0, V is equal to A omega, right? So V is equal to A omega. What about in the amplitude? The velocity is minimum. What's the value? Velocity is 0. Look at this one, the 5/2. The velocity is 0. So V minimum, the value is 0. What about the acceleration, guys? At the fixed point, acceleration is 0, right? Acceleration is 0. So A minimum is equal to 0. What about the A maximum value? A maximum, what is the value? A omega square. A omega square. Here also A maximum. A maximum. A omega square. Again, I'm telling you, for these V maximum and A maximum, we are considering only the magnitude, not the directions. Don't confuse, okay? Right. So these are the summary. In statement questions, in ABC statement questions, they will ask you, in the fixed point, the displacement is 0, the velocity is maximum. The first statement. The second statement they will give you, like, that is correct. The second statement they will gives you like, in the amplitude, the acceleration is maximum. In the amplitude, the acceleration is minimum. In the fixed point, the acceleration is maximum. Is it correct? No, it's not, because the fixed point acceleration is minimum 0. And the maximum is A omega square at the amplitude. Okay, right. So that's all. So please write this summary in your exercise book. So these kind of summaries are helps you to do MCQ and the other problems. Okay. So these summary notes are very important. After completing each and every chapters, we need to write down the summaries. Okay. Within those summaries, we can easily catch the points. Okay. Right. Write this down. Okay, right. So now guys, I'm going to draw another graph here. I'm going to draw another graph here. So the three graphs we completed, the fourth one, acceleration, displacement graph. Acceleration, displacement graph, AX graph. AX graph. Put the heading. AX graph. For this AX graph, what is the equation I'm going to use here? Can anyone guess? What is the relationship? What is the equation related to A and X? For the acceleration, we study two equations. A is equal to minus A omega squared sine omega t, one equation. What about the another one? A is equal to SHM equation minus omega square X. That's all. That's all. So look at this one. A is equal to minus omega square X graph. So this is looks like, look at this one. Y is equal to minus mx. So the gradient is what? Omega square. The gradient of the graph is omega square. So how to draw the y is equal to minus mx graph? How to draw y is equal to minus mx graph? Y is equal to plus mx graph. That will be looks like this. This is y is equal to plus mx. Minus mx means like this. So the graph looks like this. So the graph looks like this. So y is equal to minus mx graph. So the graph looks like this, okay? Acceleration, displacement. Okay, right. Can you tell me if, look at this one, look at this one. If x is equal to naught, a is equal to what? If x is equal to naught, a is equal to naught. In the displacement, if displacement is zero, acceleration also zero. Look at this one. Displacement in the acceleration, if the acceleration is zero, displacement is zero. If the displacement maximum, acceleration is maximum. So look at this graph. In this graph, if we substitute x is equal to 0, a is equal to 0, if what is the maximum value for the displacement? What are the maximum value for the displacement? Plus a and minus a, you know. For the x, what is the maximum value? So where the object can go, the maximum displacement. What is the maximum displacement of SHM? That is what? Amplitude. Yeah. So we can substitute. When we substitute plus a here, for the plus a, what is the acceleration? When we substitute plus a here, what is the acceleration? Plus a into minus omega square is equal to minus a omega square, because we substitute for the x plus a, right? Plus a. So the plus a, the acceleration is minus a omega square. When we substitute minus a here, when we substitute minus a here, for minus a, what is the value for the acceleration? Minus into minus, plus. So plus a omega square. So here, this is plus a omega square. So this is the graph for the acceleration displacement graph. Draw this graph. So if x is equal to plus a, therefore a is equal to minus a omega square. If x is equal to minus a is equal to plus a omega square. Write this down also. Okay, this one also. Okay, right. So, okay, I'm going to, right. So that's all. So those are the graph we studied today. And also there is also one graph that is like force graph, force time graph, force displacement graph. That is very easy. Okay, I'm going to give you a small note. In the next class, I'll give you the clear note for that one while doing the questions. Look at this one. I'm going to give you a hint. Okay, right. Look at this one. So there is a object that is making like a simple harmonic motion from here to here. This is plus a and this is minus a. So I told you that the acceleration is always towards the center, means the fixed point, okay, the main point of the fixed point. Okay, right. So acceleration is always towards the center. What about when the object is here? Now tell me, acceleration always towards the center. Okay, always towards the center. The acceleration is now here. Let's say the mass of the object is simple m. Let's say the mass of the object is simple m. What we can apply here is we can apply the F is equal to ma equation. No, right? F is equal to m into a. So the mass of the object is constant while it's moving in this motion. In this question, the mass of the object is constant. If mass is constant, what you can see? Very good. If mass is constant, force proportional to acceleration. If force proportional to acceleration, if force proportional to acceleration, if force increases, acceleration increases. If force decreases, acceleration decreases. Here, if force increasing and decreasing, acceleration also increases and decreases. Okay, this will happen. So force and accelerations are proportional. So if this is the xt graph, this is xt graph, that will be looks like, sorry, at graph. I'm going to draw the at graph here. At graph you studied like this, no? This is at graph, no? Okay, right. This is at graph. So in this at graph, guys, we know that acceleration time graph, if it looks like this. What about the ft graph? Is it the same? Why? If A increases, force increases. If A decreases, force decreases. Okay, right. So the ft graph also same like this. If AX graph looks like this, what about ft graph? Fx graph. What about fx graph? Is it also same? Looks like this. The difference here is the values. For the force, we need to apply F is equal to ma. So we need to multiply the acceleration by mass. So when we multiply the acceleration by mass, so here this is a omega square. So m a omega square. You got it? Because F is equal to ma, no? So this is the value for the acceleration. So we want to substitute here the force because this is the force axis. So here this is force, F is equal to ma. So acceleration into mass is force. So here also what's the value? Minus ma omega square. That's all. So this is same as a and this is minus a. Why? Because x-axis that is constant. That's not changing, right? Okay. So this is how we can draw the ft and fx graph as well. Okay, right. So these are the graphs you can see in your simple harmonic motion question paper. Okay, right. And also we have one more topic, that is the energy. The energy, we want to study about the potential and the kinetic energy in a simple harmonic motion. Can you tell me what about the kinetic energy at the fixed point, maximum or minimum? Kinetic energy of this point is maximum or minimum? Maximum. Why? Because the velocity is maximum, no? Kinetic energy. Do you know the equation for the kinetic energy? What is that? Half mv square. If the velocity increases, kinetic energy will increases. If the velocity is no zero, kinetic energy is zero. So we want to study those part in the next lesson. Okay, right. Look at the second question. So in that question, they given a graph there. So in that graph, can you tell me what is the T of the graph? That means what is the period of time of that graph? This is XT graph, right? XT graph. So can you tell me, guys, what is this? This is from this point to this point. Look at here. Look at here. Look at here. From this point to this point, I'm taking for an example for this graph. I'm taking example for small example. So this is from this point to this point. What is the time difference between these 2 points? This is T by 2, 3T by 4T. What is the time difference? T by 2. You got it? Because this is T by 2, no? So the time difference here is T by 2. So what is the T by 2 value there? So I think that is not clear, right? It's like no, here. Look at this one. Huh? In this graph, for an example, yeah, I'm going to tell you for this graph only. Yeah, look at this one. Look at this one. Please plot the graph like this. Huh? The graph looks like this. No, this is 0.2, guys. Huh? This is 0.2. This point, and this is 0.4. Okay, right. So the center here is 0.3. Mark it like this. This point is 0.2. This point is 0.4. Okay, now tell me, students, can you, right, okay. This is T by 2, no? This is T by 2. You told me that this is T by 2. What about these 2 points? Here, look at this question. Look at this question, huh? Right. What about these 2 points? Tell me, what is the time difference between these 2 points? This is 7T by 4. This is 3T by 4. What is the time difference? 7T by 4 minus 3T by 4. What's the value, guys? 4T by 4 is what? T. So here in this graph, this is what? T. T is equal to what? 0.2. This is 0.4. This is 0.2. What's the value? 0.2. So we can get the answer for this one. The period of time is 0.2. This is how we want to extract the data from the graphs. Okay, you got it. So please be aware about those graphs. So what you want to do here is, guys, you want to do the second one, the homework sheet, the second question you should do. Please mark the questions. The third question. Third question. Third one. Please wait up. Third one. Do the question number 8. Question number 9. And then try to answer the question number 13 as well. Question number 13. Question number 13. Okay, so those are the questions I'm giving you today in the homework sheet. You should complete this homework before coming to the next class. This is how you want to do. You want to take separate book for the homework book. Okay, right. So the theory is separate. Okay, the theory book is separate. So the theory you should maintain in a different book, exercise book. So today we studied the theory part now. So while doing the theory part, we will do some numerical questions in the theory part to understand the theories. Okay, that is, those questions are examples. That is different. The homework sheet, those homework sheet, what you want to do here is, you want to, when you go to home, when you want to complete all the theories and try yourself. So you should write down the answers. If you don't know any answer for the question, don't leave space there. If you know the answer, please write it down. If you don't know, please don't leave any space between the questions. Just write down the answers. When you are coming to the class, we can discuss those questions, and I will, you can correct the question, is it correct or not? Okay, you can correct those things. And for the MCQ also, you can maintain a separate, but in the same homework sheet, you can follow the MCQ question as well. Can you take out the MCQ question, multiple choice question? Okay, in that question, please try to do the question. No, we need some, yeah, we need to study more. Yeah, we'll study, we do this later. Okay, right. We'll do those questions later. So while coming to the next class, please do all the homeworks. Okay, right. So those are the things. So here, okay. So today, what we studied, we summarized the simple harmonic motion, and I told you about the, I already explained you the last class. I explained you the equations for the, we derived those equations from the projection of the circular motion. So x is equal to a sine omega t, v is equal to a omega square cos omega t, and also a is equal to minus a omega square sin omega t. These are the equation. And from this equation, we derive the equation a is equal to minus omega squared x. That is the equation for the simple harmonic motion. If there are any motion happening in this equation, like if there are any motion satisfy the equation a is equal to minus omega squared x, that is a simple harmonic motion. Okay, right. When they are giving a equation, we can extract the data like omega. We can, when they are giving the equation a is equal to minus omega squared x, like minus 16 square x, we can extract the omega data from that equation, and from the omega, what are the data we can find out? What are the parameters we can find? T, we can find the T, we can find the F. Okay, right. These are the things we can find it out using those equations. And after that, we move to the graph session. In the graphs, what are the graphs we discussed? XT graph, displacement time graph, velocity time graph, and acceleration time graph, and also acceleration displacement graph. In the, yeah, the displacement time graph, that is like a sine curve. Okay, right. The velocity time graph, that looks like cos graph, and also acceleration time graph, that is looks like minus sine graph, minus a omega, no, sine a omega square sine omega t, no. So that is looks like minus sine graph. Okay, right. And also we studied about the a is equal to minus omega squared x. So a graph as well. So that a is equal to minus omega squared x graph looks like y is equal to minus mx graph. Okay, right. Those are the graph we studied. And also we studied about the relationship between the acceleration and the force. What is the relationship between the acceleration and the force? F is equal to m into a. So the mass is, if the mass is constant, force proportional to acceleration. So the shape of the acceleration time or acceleration displacement graph is the same for force, time, and force displacement graphs. Those are the things we study today. So in our next class, we'll move to the energy, and some systems. We'll analyze the systems of simple pendulum and spring mass system, and other systems. We'll derive the equation for the periodic time. Okay, right. That's all we'll study now. We'll meet in our next class. So thank you so much. See you all, guys. Okay. Sorry. So most probably it will happen on Tuesdays. Okay, right. That's all. Sorry. So there's a group, right? So please add these students in the group. Okay, right. That's all. So we'll meet. So if you have any doubt, you can ask me now. Okay, right. So you can get my number, WhatsApp number as well. So my number is 0777425 707. Okay. So you have the number, right? You can share with others. Okay. 0777425 707. 777 425 707. Okay, right. So we'll meet. Okay, bye.